Hello guys, welcome to Amazing Engineering, and today in this GeoGebra tutorial we will see how to design a pantograph mechanism applied on a Chebyshev mechanism. As first, let's design the Chebyshev mechanism. Let's set the first fixed rotary joint called A0, whose coordinates are 0, 0. Let's make a slider called A, which varies from 0 to 5, and we will design the whole mechanism using only these parameters, because as you know, the length of the links of Chebyshev mechanism depend on one parameter. For example, A is the length of the frame of the mechanism, so we can set the second fixed rotary joint B0 using the command point circle, whose center and radius are A0 and A. So this is the point B0. Now we can design the rest of the mechanism as we did in the first video tutorial. So let's create a circle centered in A0 and with a radius equal to 0.5 times A. Let's choose a point on this circle, for example this one. Let's create an angular slant, an angular slider called alpha, which varies from 0 to 360 degrees. Click on angle with given measure. Select the point A, the point A0. Now we have to set the angle of rotation, which will be the angle of the crank of the mechanism. This angle is the slider alpha, and we can set, for example, a clockwise rotation. Let's hide the angle, the point A and the circle. Now let's create other two circles. The first one centered in the point A and with a radius equal to 1.25 times A. And the second one centered in the point B0 and with the same radius. Let's intersect the circles. We can choose the first intersection point. Let's hide the circles. Now let's create another circle centered in B and with the same radius, so 1.25 times A, and a line which passes through the point A and B. Let's intersect the circle and the line. We can choose the second intersection point. We can call it M. And now we can link all the points. So this is the Chebyshev mechanism, and we can check it showing the trajectory of the point M. Let's animate the mechanism. And as you can see, the point M makes the characteristical trajectory of the Chebyshev mechanism. Now we can design the pantograph mechanism in order to amplify the trajectory of the point M. As first, let's set another fixed rotary joint called C0, whose coordinates are 10 and 2. Let's create other sliders. The first one is called, for example, M5, which varies from 0 to 6. And other two sliders called L1 and L2, which represent the length of the parallelogram mechanism. For example, L1 varies from 0 to 9, and L2 varies from 0 to 7. Let's create other two circles. The first one is centered in C0 and its radius is equal to M5. And the second one is centered in the point M and its radius is equal to L1. Let's intersect the circles. We can choose the second intersection point. Let's create another circle centered in the point C and with the radius equal to L2. Let's create a line passing through the point C0 and C. Let's intersect the line and the circle, and let's choose the second intersection point. Now let's create other two circles. The first one centered in the point M and with the radius equal to L2. And the second one is centered in the point D and with the radius equal to L1. Let's intersect the circles. Let's choose the first intersection point. Let's hide the circles and we can link the points. Now, in order to complete the pantograph mechanism, let's make two lines. The first one passes through the point C0 and M, and the second one passes through the points D and E. Let's intersect the line. Let's link the points E and F. And this is the pantograph mechanism. We can check it showing the trajectory of point F and M. And if we animate the mechanism, as you can see, the point M and F make similar trajectory, but the trajectory on the point F is bigger than the trajectory of the point M. So the trajectory has been amplified. Well, this is all for today. I invite you to subscribe on my channel and see you for the next video.